Hi everyone. Is my screen visible to everyone? Am I audible to you all? Good morning, Pooja. Good morning, Hashini. Am I audible and is my screen visible to everyone? Good morning, Krishna. Yes, put it in the chat. Okay. Good morning. Good morning, everyone. Okay, so in today's class, we are going to discuss the questions on amines. Okay. And yesterday itself, I've told you to go through the chapter. Have you all revised the chapter once? Have you all revised the chapter once? So in this unit also, like yesterday, we have discussed few questions in aldehyde ketones and acids, right? So the questions were based on like few naming reactions, and the complete question is on the conversion only. Okay, so reactant will be given. You have to predict the product, or you have to predict the reagent. The same thing applies to the unit of amines also. So just go through the important topics in amines is like go through all the naming reaction ones and important conversions. Okay. For instance, how will you convert like nitrobenzene to aniline? Benzene to aniline. Okay. How will you convert this nitrobenzene to alcohol or to halide? Something like the conversion. You have to go through the conversions. Okay. And same thing applies for the benzene diazonium fluoride. Benzene diazonium fluoride to benzene. Benzene diazonium fluoride to phenol. Okay, to aniline. So those coupling reaction. Okay, and benzene diazonium fluoride to its corresponding halide like bromobenzene, chlorobenzene, iodobenzene, how it works. So all the halobenzenes. Okay, so these are few important things to revise in this chapter. Okay, so the questions will be based on these things alone. So be thorough with the naming reactions. Okay, so here like important naming reactions will be like Hoffman bromamide degradation, then Sandmeyer reaction, Gatterman is, and then and the important conversions. Okay, so Hoffman thalamide synthesis. Okay, so how does nitro compounds undergoes electrophilic substitution reaction? Aniline undergoes electrophilic substitution reaction. So these are few important things to revise in this chapter. Right. So moving to the question part. Okay, so in today's class we are going to discuss the PYQ, the previous year question on amines. Okay, so you'll get an idea like what type of question will be asked in the exam. Fine. So it is a numerous a nitro compound 135 plus 4 nitrophenyl benzene on complete reaction with excess of 10 treatment with an excess of NaNO2 HCl at 0 degrees Celsius provides P as the product. P upon treatment with excess of water at room temperature gives the product Q. Bromination of Q in aqueous medium furnishes the product R. The compound P upon treatment with an excess of phenol under basic condition gives the product S. The molar mass difference between compounds Q and R is given as 474 kilogram per mole, and between compound P and S is 172.5 gram per mole. The number of heteroatoms present in molecular R is the question. Okay, so we have to find out like up to R. Okay, and the clue, what is the hint given is like here, the molar mass difference between compound Q and R is 474 gram mole inverse, and P and S is 172.5 gram mole inverse is the given. Okay, so this is like a reactant is given and a series of reaction goes on to give the unknown product. We have to find out like what is P, what is Q, what is R, and what is S. Okay, so compound 1,3,5 tris 4-nitrophenyl benzene. It is a trinitro compound. So you'll be having like 3 NO2 groups. Okay, and the IUPAC name is given. From the IUPAC name, you're going to write the structure. Okay. So write down the structure in your notebook for 1,3,5 tris 4-nitrophenyl benzene. Okay. Everyone write down the structure for 1,3,5 tris 4-nitrophenyl benzene. Okay. So what you have to do, like what is the parent over here is benzene. So draw benzene. Okay. And then you're going to like add the substituent like 4-nitrophenyl. 3 times you have to add. This means it means that 3 times you are going to add at the position 1, 3, and 5. Okay, you'll get the compound. Okay, so everyone write the compound in the notebook. Write the compound in the notebook. Write the compound in the notebook. It is 1,3,5 tris 4-nitrophenyl benzene. So what I'm going to do is like draw benzene. Okay. So in 1, 3, and 5. So let I take this as first position, third position, and fifth position. So in 1, 3, and fifth position, 4-nitrophenyl you have to add. Okay. So again, you are going to make a phenyl ring. Okay. So it means that para-nitrophenyl. So NO2 and again NO2. So have you all got the structure? So this is the structure of 1,3,5 tris 4-nitrophenyl benzene. Okay, so have you all got the structure? Everyone, have you all got the structure? Yes, fine. So now what I'm going to do is like on complete reaction with excess of 10 HCl. So when a nitro compound reacts with 10 HCl, what product you'll be getting? Nitro compound on reaction with 10 HCl. What is the product you'll be getting? Nitro compound on reaction with 10 HCl. What is the product you'll be getting? What is the product? It undergoes reduction, right? So you'll be getting RNH2 as the product. So where you have like nitro group, you just convert it into NH2. Okay. So with an excess of 10 HCl, it gives a major product. So I'm going to convert all the NO2 to NH2. We have benzene and at the para position you have NO2 group, it will get converted to NH2 group. And here too you have NO2 group, it will get converted to NH2 group. Okay. So now I got the major product. So this is your major product, which on treatment with excess of NaNO2 HCl. So when aniline reacts with NaNO2 HCl at 0 degrees Celsius, what you'll be getting? Aniline on reaction with nitrous acid. NaNO2 HCl is mixture of nitrous acid mixture is sodium nitrite and HCl. Okay. So what is the product when aniline reacts with NaNO2 HCl? It's in the chat box. Good morning, Nishant. Yes. What is the product? Put it in the chat box. Phenol. Sorry. Aniline on reaction with nitrous acid. At 0 degrees Celsius, what you'll be getting? You'll be getting benzene diazonium fluoride. So wherever you have like NH2, it gets converted to benzene diazonium fluoride. Okay. So just convert, you have like NH2, put benzene diazonium chloride, N2 plus Cl minus. N2 plus Cl minus. Okay, so I'm going to write it down. Like when you react it with NaNO2 HCl at 0 degrees Celsius, so you have like NH2 group. All these three NH2 group will get converted to N2 plus Cl minus. So N2 plus Cl minus. N2 plus Cl minus. Okay. So now this is your product. Now I got P. Now I got. Okay. So what we have done, we have taken 135 plus 4-nitrophenyl benzene on reaction with tin HCl. Nitro group will get converted to NH2 group. So we'll be getting all the NO2 group is converted to NH2 group. Now we know that aniline on reaction with NaNO2 HCl will be getting benzene diazonium chloride. So all the NH2 group are okay. Now, T on treatment with excess of water. Now you are treating it with water. Okay, when you are treating it with water, what will be Q when benzene diazonium chloride, when it undergoes hydrolysis? What would be Q? What product you will be getting? Benzene diazonium chloride on hydrolysis. What product you will be getting? Just do hydrolysis. So what will happen when you do hydrolysis? When you do hydrolysis, the bond will break over here. So nitrogen gas will be evolved, HCl will go out. So you'll be getting OH. So benzene diazonium chloride on hydrolysis will give you phenol as the product, right? So wherever you have like N2 plus Cl minus, what we are going to do? Convert it into OH. Okay, you're going to convert it into OH. So therefore, I'll be getting just convert all the N2 plus Cl minus to OH. So wherever you have like N2 plus Cl minus, put OH. So OH, OH, OH. This of H2O gives Q as the product. So now this is resistance of Q in aqueous medium will give the product. Okay. Now I'm going to do the bromination. Now, like where does the bromination will take place when there is an electron releasing group? Now tell me, like OH is an orthopara director or a meta director? OH is an orthopara director or meta director? OH is an orthopara director or a meta director? All the electron releasing groups are orthopara director. Yes, it is an activating group. It is a ring activating group. So where does the bromination will happen? At ortho and para position. So when you look over here, para position is completely occupied. So where does the bromination will happen? At ortho position. You put Br, Br. Okay. And then you have benzene. Para position is occupied. So at the ortho position, you put Br. So here to para position is occupied. So at the ortho position, you put Br. Now this is your R. This is your R. Okay. So now what you have to find out is the number of heteroatoms present in one molecule of RS. And what is the clue given? If you molar mass difference between Q and R is 474 gram per mole. So when you just check, right, take the molar mass of Q, take the molar mass of R, and when you check it, the molar mass different, it should be like 474 gram per mole. Okay, so if it is true, then the compound what we have obtained is right. Now what you have to check of R is, so what is the number of heteroatom present in this molecule? What is the number of heteroatoms present in this molecule? What is meant by heteroatom? Heteroatom are the atoms which like other than carbon and hydrogen. Yes. So we know, so if there is like any atom like other than carbon and hydrogen, that is if you have like oxygen, if you have like sulfur, all these are heteroatoms. So just count the number of heteroatoms in R and tell me the answer. Put it in the chat box. How many heteroatoms you have? You have in R. Okay. So I have like 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. So your answer is going to be like 9. Okay. So the answer is 9. 9 is your answer. Okay. Clear with this question, everyone? Do you have like any doubt in this question? Shall I move to the next question? Clear with this question? Do you have any doubt? Shall I move to the next question now? Okay, fine. So moving to the next question. Okay, so the same question, but here what they have asked is the total number of carbon atoms and heteroatoms present in the molecule SS. So in the previous question, we have evaluated up to R. We have evaluated up to R. Okay, now we are going to find out the product atoms present in one molecule of S. So how S is obtained? T upon treatment with excess of phenol under basic condition gives the product S. Okay, so what is P for it? So since the question is same, I'm taking P. Okay, so what is P? This is your P. Okay, so P upon treatment with excess of phenol under basic condition, it will give like product S. It will give the product S. Determine the product. Okay, so what I have is benzene diazonium fluoride. When it reacts with phenol, C6H5OH, when it reacts with phenol, can you like tell me the name of the reaction? Benzene diazonium fluoride with phenol. What can you prepare from this reaction? Benzene diazonium fluoride with phenol. What it is, like you have, very good, dye. Okay, you'll be getting dye. So it is a coupling reaction. It is a coupling reaction. So what happens in coupling? Excuse me. So what happens in coupling and double bond and Cl minus? Yes. So you'll be having this. Now what happens? It reacts with phenol. So HOH, phenol. So now this HCl will be removed. So I'll be getting N double bond N and C6H4OH. So we'll be getting the dye as the product. So what we are going to do, again write the compound P, what we have done in the previous question, and put excess of phenol, you'll get the molecule S. So now in the molecule of S, you have to count the total number of carbon atoms and heteroatoms present. Okay, so I'll write P first. So here you have like N2Cl and benzene ring. You have like N2Cl and N2 plus Cl. Okay. So now what I'm going to do is like react it with excess of phenol. Excess of phenol. So wherever this N2 plus Cl minus is there, you'll be getting the compound like C6H5 and double bond N C6H5OH. This is the compound you'll be getting. Okay. So what I'm going to do is, right, I'm going to write the final compound S. So I have like N2 plus Cl minus S. So this N double bond N, I'll be getting N double bond N, and version you have to, okay. So to all the three benzene diazoxide chloride which is attached over here, you are going to write the product like this. OH. And again here it is should be attached to the para position. Attach it in the para position. Okay. N double bond N C6H5OH. Here too it will be like N single bond N double bond N C6H5OH. Now what you have to do is like count the total number of carbon atoms and heteroatoms and tell me the answer. Count the total number of carbon atoms and heteroatoms and tell me the answer. Total number of carbon atoms and heteroatoms in the compound. So how many rings you have? Like 1, 2, 3, 4, 5, 6, 7 rings you have. Okay, so 7 into 6. And then you just count the number of heteroatoms. So in one thing you have like 1, 2, 3. 9 you'll be having. 9. So it will be like 51. So your answer is going to be like 51 is your answer. Okay. So you have like in one part, you have 1, 2, 3 heteroatoms. And you have like how many rings? 1, 2, 3, 4, 5, 6, 7 rings. 7 rings contain 6 carbon. So 7 into 6 is 42. And you have like 9 heteroatoms. So therefore, total it is going to be like 51. So 51 is your answer. Okay. So clear with this question, everyone? Are you clear? Shall I move? Yes, I will repeat. I will repeat. See, the compound T upon treatment with excess of phenol under basic condition, it gives yes, okay? Reacts with phenol, it gives a coupling reaction. So you will be getting a red orange dye, okay? It is a well-known coupling reaction. Now what I'm going to do is like, I'm going to do the same with wherever I have N2 plus Cl minus. So wherever I have N2 plus Cl minus, I'm going to write this compound, okay? So it will be like C6H4 and double bond and C6H4OH. Here too and here too. Now what I'm going to do is like count the total number of carbon atoms and heteroatoms. You have like 7 rings. So 7 rings contain 6 carbon atom, 42. And you have like 9 heteroatoms. So 42 plus 9 is going to be like 51 is your answer. Okay. Clear? Yes. So moving with the next question. The total number of sp2 hybridized carbon atom in the major product P, which is a non-heterocyclic compound of the following reaction. Okay, what you're going to do, you're going to evaluate this reactant and find out the product P. Okay, so what is given over here is lithium aluminum hydride excess you're putting, so it can react with all the CN over here, and then you're doing hydrolysis. And then you're reacting with it with excess of acetophenol. Then you have to count the total number of sp2 hybridized carbon atoms. You'll get the answer. Okay, in the product P, you have to count. So what we have to know is like when RCN, nitrile group, reacts with lithium aluminium hydride. What would be the product form? What is this reaction in general known as? When you put lithium aluminium hydride, what is the reaction in general known as? It is a reduction. Okay, lithium aluminum hydride, since it has like excess of hydrogen, it will act as a reducing agent. So what will happen over here is like reduction happens. So you have like two pi bonds. So how many electrons you have? Like 4 electrons, right? So what will happen over here is like it will form two hydrogen and two hydrogen will be added. Two hydrogen will be added. Totally, these 4 hydrogen will be added on the pi bond. We know that whenever there is a pi bond, addition reaction will happen. So you'll be getting like R, CH2, NH. Okay, you'll be getting amine. You'll be getting amine as the product. Now what you're going to do is like you're going to hydrolyze this amine and put acetophenone. Okay, you're going to do the hydrolysis, and what you're going to do is like react it with acetophenone. So what is acetophenone? PHCOCH3 is acetophenone. So when you do hydrolysis, what will happen? When you do hydrolysis, what will happen over here? So you're doing hydrolysis, okay, reacting it with like acetophenone. So when I react it with like acetophenone, this oxygen and this hydrogen will be removed as water. Will be removed as water. So what you'll be getting is R CH2N double bond. What you have? C CH3PH. This is what I'll be getting. Okay, so this is the general thing. I'm going to do it in this compound. Okay, so we know that nitrile on reduction gives amine. Amine on reaction with acetophenone will give like N double bond C will be formed. Okay, water molecule will be removed out. So just do it in this equation now. So I have CN, 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 CN. So all the CN in the first step will get converted to NH2. So when I put like lithium, aluminium hydride, and water, and you're doing hydrolysis over here, so CH2, NH2, what happens? Two hydrogen and two hydrogen will be added by breaking the pi bond. CH2, NH. Okay. Now what you're going to do is like react it with excess of acetophenone. So what is acetophenone? COCH3 is acetyl group, and you will be having PH, acetophenone. Now what will happen? H2O will be removed everywhere. So you'll be getting like CH2N double bond C, PH, CH3. CH2N double bond C, PH, CH3. Again, CH2N double bond C, PH, CH3. CH2N double bond C, CH, CH3. Now, this is your product P. Okay, it is a non-heterocyclic compound. And now, what will be the number of sp2 hybridized carbon? So, what is the number of sp2 hybridized carbon over here? Yes, your answer is right, Aditya. It is 28. Okay, just count the number of sp2 hybridized carbon. So, in each phenyl, like you have like six carbon, which is sp2 hybridized. Okay, so you have like 1, 2, 3, 4 phenyl groups. So all the four will have like 6 sp2 hybridized carbon. Yes, this is sp2, sp2. So everywhere it is like sp2 hybridized. So you have like 4 phenyl groups. So 4 into 6 is equal to 24. Okay, 24. And here you can see like 1, 2, 3, and again 4. So 4 sp2 hybridized carbon in the side chain. Here you can see. Okay, C double bond N, C double bond N, C double bond N, C double bond N. So plus 4 is going to be like 28. So your answer is 20. Okay, clear with this question, everyone? Clear? Shall I move to the next question? Are you all clear? Yes, fine. So moving with the next question. The reaction of X gram of 10 with HCl quantitatively produced a salt. The entire amount of the salt reacted with Y gram of nitrobenzene in the presence of required amount of HCl to produce 1.29 gram of an organic salt. Salt quantitatively, what would be the value of X is the question. Okay, so reaction of X gram of 10 with HCl quantitatively produced a salt. Okay, so 10 with HCl will give a salt. The entire salt reacted with Y gram of nitrobenzene in the presence of required amount of HCl to produce 1.29 gram of organic salt. What would be the value of this? Okay, so like reaction of X gram of 10. So 10 reacts with HCl quantitatively. It means that you have to balance the equation. Okay, 10 with HCl quantitatively produce the salt. Entire amount of a salt react with Y gram of nitrobenzene. So you are going to react it with Y gram of nitrobenzene. So it is X gram, it is Y gram. In the presence of required amount of HCl to produce 1.29 gram of organic salt. So you'll be getting an organic salt over here. Now, can you tell me like what will be formed when 10 reacts with HCl with nitrobenzene? When nitrobenzene, this reaction already we have revised now. Okay, nitrobenzene on reaction with 10 HCl. What is the product form? What is the product form? Very good. It is aniline. Okay. NO2 on reaction with 10 HCl. First, it will form aniline. That is, you'll be getting NH2. Now, what I've asked is like, you need an organic salt. Okay. So again, what will happen? This one will react with tin and HCl will produce a salt called tin chloride. Okay, tin chloride in presence of HCl, you'll get NH3 plus Cl minus. Cl minus. Okay, so now this NH3 plus Cl minus is 1.29 gram. Okay, what you have to find is like you have to find out what is X. What is X? Okay, so the mass of organic salt produced. Okay, so that is the aniline which is produced is 1.29 gram. What would be the molar mass of aniline first? Okay, we'll calculate the molar mass of aniline. So what will be the molar mass of the organic salt? What would be the molar mass of organic salt? It will be like something 129 gram per mole. Okay. So using this, what we can calculate, you know the weight, you know the molar mass. So you can calculate the number of moles. So number of moles is equal to mass by molar mass. Mass is 1.29. Molar mass is 129, which is 0.01. Okay. Now I got the number of. So from 1 mole of salt is produced. Now what we have to do is like we have to balance the equation. We have to balance the equation so that we'll get the stoichiometric ratio. So using it, we can evaluate the question easily. So first we'll balance this equation. So 3 times of 10 reacts with 6 times of HCl to form NH2 plus 3 times of SnCl2 plus 2 times of water will go out because we have like O2, right? So 2 times of water will move out. Now this again reacts with HCl to form NH3 plus Cl minus. Okay. Now what is the stoichiometry thing over here? 10. How many moles of 10 reacts? Like 3 moles of 10 reacts to produce How many moles of salt is produced over here? The organic salt which is produced is 1 mole. So 3 to 1. So therefore, for 0.01 mole, what will be the 10? Okay, what will be the number of moles of 10? For 1 mole, it is 3. So for 0.01 mole, what it will be? It will be like 0.03. Okay. So now I got the number of moles. What you have to find out in grams. So for it, what you need? You need the mass of 10. What is the atomic mass of 10? It is going to be 119. So 119 into 0.03 will give you the mass. Molar mass into number of moles. Molar mass into number of moles. So your answer will be like 3.57. No, it will be given in the paper itself. The atomic mass, it will be given in the paper. For most of the questions, they will give the molar mass in the paper itself. Okay. So your answer is going to be like 3.57. Okay. So this is an organic question. So in like organic questions, you can expect these type of questions by mixing the mole concept. Okay. They mix the mole concept over here. So what you have to do is like using the simple formula. We know that number of moles is mass by molar mass. So if the question is like you have to find out the required amount or you have to find out the quantity. Okay, what you have to do, you have to balance the equation. So if you balance the equation, you'll get the stoichiometry. So from the stoichiometry, from the given, you can evaluate the unknown and do the question. Okay, so it is like mixed. The mole concept is mixed in organic part. Okay, so this type of question could be asked in the numerical type. Fine. Yes. So moving to the next question. Okay, so now see the same question. What they have asked is like you have to find out the value of y over here. Okay, so what we have done in the previous one, we have evaluated x and o. Now we are going to evaluate y. So using the same thing, okay, you can evaluate the y. Okay, so can you solve this question using the same model? You can solve. Instead of x, they have asked y as the question. Okay, can you solve it? What would be the answer? Yes. Everyone try to solve this question. Very good. It is 1.23 gram. Yes. So here we know that 3 reacts with 1. Okay. So 3 reacts with 1. So therefore, 1 mole of organic salt is produced by 1 mole of nitrobenzene. So 1 and 1 is the ratio. What we have find out, it is 0.01. So nitrobenzene will also be 0.01. If you do the molar mass of nitrobenzene, it is going to be like 123 grams. Yes. So into 0.01 is going to be 1.23 grams. Okay. The same question, like in the same year, the question was like this. Okay. In the previous question, the value of x was asked, and in the next question, the value of y is asked. Okay. So what we have done is like tin plus HCl plus nitrobenzene has given the salt. Okay. We have evaluated the salt to be like 0.01. And when you have done with the stoichiometry, we have got like 1 mole of nitrobenzene reacts to give 1 mole of the salt. So 0.01 will produce again 0.01. You have to find out the value of y. So what is the molar mass of nitrobenzene is 123 gram into number of moles is 0.01 is equal to 1.23 grams. So 1.23 gram will be the answer. Okay. So in the same year, like the consecutive questions, the previous one and the next one was based on the same thing. Okay, in the previous question, value of x is asked, and here the value of y is asked. Next one. So moving with the next question. Consider the reaction sequence from P to Q shown below. The overall yield of the major product Q from P is 75%. What is the amount in grams of Q obtained from 9.3 ml of P? Use density of P is equal to 1 gram per mole. Molar mass of carbon, oxygen, hydrogen, and nitrogen are given. Okay. So what is given here? P2Q, the reaction is given. Okay. So Q is formed over here. So the overall yield of the major product is 75 percentage. Okay. So you have to find out the amount of Q obtained from 9.3 ml of P. So here 9.3 ml is given. Okay. What you have to do is like you have to convert this 9.3 ml into the number of moles. Okay. So 9.3 ml is given. Volume is given. And here density is given. Density is equal to 1 gram per milliliter. Okay. Now what would be the mass? What would be the mass? What would be the mass? Volume and density is given. You have to do with the mass. When you know the mass, we can do with the number of moles, right? So what would be the mass here? Density is equal to mass by volume. So mass will be density into volume. So which is 9.3 gram. So what would be the number of moles? Number of moles is the mass by molar mass. What is the molar mass of aniline? What is the molar mass of aniline? When you evaluate, you'll be getting 93. So which is 0.1. Now I got that P as 0.1 mole. Okay. So now what you're going to do? You are going to evaluate Q. So 0.1 mole of P reacts with these three reagents to give Q and NaOH as the product. But once you obtain the Q, then using the stoichiometry, we can solve and get the answer. Okay. We can get the amount of Q in grams. First, we will try to solve the question. What I have over here is like aniline reacts with NaNO2 HCl. What product you will be getting? Aniline on reaction with nitrous acid. What is the product? We have discussed this already, right? So aniline on reaction with NaNO2 plus HCl. What you will be getting? Put it in the chat box, everyone. What is the product when aniline reacts with nitrous acid? In cold condition, what you'll be getting? Very good. Benzene diazonium fluoride. Okay, so first one I'll be getting as benzene diazonium fluoride. Yes. What is the second step? What is the second step? You're reacting it with this compound. What is this compound? Naphthol. Okay, naphthol. So it is beta naphthol. When you react it with beta naphthol, we know that when benzene diazonium fluoride reacts with phenol, what product will be getting? Just now we have seen the reaction, right? Benzene diazonium fluoride with phenol. It will undergo coupling reaction to form dye. The same thing happens over here. Okay, so what will happen is the para position. Okay, so here like you have beta naphthol. So when it reacts, okay. So here the para position is occupied with one benzene ring. So where does this one will attack? It will attack at the ortho position. So therefore, you will be getting the hydrogen from the ortho position and Cl minus will move out to form OH. So here it will be N double bond N. And you'll be getting that. Okay. So now you got this red orange dye. Red orange dye. Now we are going to react it with acetic acid. Okay. So alcohol with acid will give you very good. It will give you Alcohol on acid will give you, yes, ester. So what you'll be getting? Like ester in presence of water. So you'll be getting, okay, now we got this. Yes. So now you got Q. Now what you're going to do, like we have got 0.1 mole. Okay, so 0.1 mole will produce how many amount of mole of compound of Q? It is also 1 mole. So 1 gives 1. It means that 0.1 mole gives 0.1 mole of the compound Q. Okay, but according to the question, the major product overall yield is 75 percentage. 75 percentage. So what we are going to do is like multiply it with 75 percentage. So 0.75, okay, 0.75 into this molar mass. So find out the molar mass, multiply it with, you'll get the answer. You'll get the answer, okay. So this numerical part, I'm leaving it to you. You'll get the answer. Fine. Yes. Moving to the next question. Now the next question is scheme 1 and 2 describe the conversion of P to Q and R to S respectively. Scheme 3 describes the synthesis of T from Q and S. The total number of bromine atom in a molecule of T is the question. Okay, so I have just separated the scheme 1, scheme 2 and scheme 3. Okay, so what we are going to do is we are going to evaluate until T and find out the total number of bromine atoms in the molecule. Okay. So what I have is like I have aniline with excess of Br2, bromination in presence of water. What product you will be getting? You are putting excess of Br. So where does the bromination will happen? Very good. Tribromoaniline at both the ortho and para position. So Br, Br, Br. Now what we are going to do is like react it with NaNO2HCl. Now tell me the name of the reaction. What will be formed or what is the name of the reaction? Diazotization. So you'll be getting, what is the product you'll be getting here? You have NH2 react with NaNO2HCl, benzene diazonium fluoride. So N2 plus Cl minus Br, Br, Br. Now what you're going to do is like react it with CuCN KCl. CuCN KCl. Can you tell me the name of the reaction? Can you guess the name of the reaction? You have benzene diazonium fluoride. Yes, Gatterman reaction. So see, you got a naming reaction over here. So when it reacts with CuCN, what you'll be getting? N2 plus Cl minus will get converted to Cn. So here you'll be getting Cn, Br, Br, Br. Yes. Now you are doing hydrolysis. Fine. So Cn on acid hydrolysis, complete hydrolysis. What is the product you'll be getting? Cyanide on complete hydrolysis will give you, excuse me, very good, acid. It will give you acid. COH, Br, Br, Br. Yes. Now what you're going to do is react with thionyl chloride. So acid in thionyl chloride will give you Acid on reaction with thionyl chloride. What is the product you'll be getting? RCOOH with thionyl chloride, SOCl2. Yes, fine. You'll be getting COCl2. Okay, so HCl will be removed and SO2 gas will be removed. You'll be getting RCOCl. Okay, acyl chloride as the product. So here I'll be getting it as like COCl. Okay, this is your Q. Now I got Q. This is your major product. Okay, so clear with this conversions? It is like easy conversions only. It is not like very hard. Okay, it is very well known. Reagents are given. Fine. So that is why I'm telling like go through, be thorough with the naming reactions. Frequently naming reactions will be asked in the conversions. Now, what is the scheme 2S? Scheme 2S, R will give S. So what is R first? Okay, P to Q and R to S respectively. Okay, so R to S. So R given is like benzene. Benzene on reaction with oleum. What is oleum? Oleum is mixture of sulfuric acid and SO3. Yes, H2SO7. Okay, so sulfuric acid with SO3 is oleum. So this is used as where we'll be using this oleum in electrophilic substitution reaction sulfonation. In sulfonation. So this instead of oleum, they can give also as fuming sulfuric acid. Fuming sulfuric acid as well as oleum. Okay, it will give, it will undergo sulfonation reaction. So when you react it with H2SO7, sulfonation happens. So you'll be getting benzene sulfonic acid. Now what you're going to do? React it with NaOH and heat it. What will happen? When you react an acid with a base, it will form salt and water. So remove water molecule. So H2O will be removed. So you'll be getting like SO3 plus, sorry, SO3 minus Na. You'll be getting the salt. Okay. So water is removed, you'll be getting the corresponding salt. Now this on reaction with H plus. When you react it with H plus, what will happen over here? Leaving one oxygen. Okay, all the other will be like removed. Okay, so you'll be getting like H phenol you'll be getting. And you're reacting phenol with Br2CS2 carbon disulfide at 273 Kelvin. What would be the major product? Yes, monobromidation happens. So OH. So they have asked the major products. I'm writing the para product as the major product. So this will be your S. This will be your yes. Fine. Whereas the ortho product will be the minor product. So I need a major product. So I have written the major product. Now, in the scheme 3, major product, that is your para-bromophenol. Para-bromophenol on reaction with NaOH and on reaction with Q will give T as the product. Okay. So para-bromophenol Br on reaction with NaOH. So we know that like this para-bromophenol is very acidic in nature. Is because of the electron withdrawing group, it is acidic in nature. NaOH is the base. Now what will happen again? Salt. It will form salt. And water molecule will be removed. So remove water molecule. So H plus, since it is an acid, it will give out H plus. Base will give out OH minus. So water will be removed to form O minus Na plus, will be getting the salt Br. So sodium salt of para-bromo-phenol. Yes. Yes, Aditya. Yes, do you have like any doubt? Okay, fine. Yes. So now what we are going to do is like react it with Q. React it with Q. So what is Q we have got here? We have got the Q as tribromobenzoyl chloride is the Q. Okay, so I'm going to react it with. So just react it with Q. So Br, tribromobenzoyl. Okay. Now what will happen over here is I'll write it as like C double bond O C. Yes. Now due to this electronegativity of oxygen, it will have partial negative charge and it will have a partial positive charge. So now this O minus will go and attack this electrophilic point. Okay, C. And this bond will move out as like O minus. So what you'll be getting over here is I'll be getting Br. Okay, Br, Br, and then here it will be like carbon, oxygen, which is attached to carbon, O minus Cl. Cl. And here, yes, we'll be getting this. Okay. So now ring is connected to carbon directly. Yes. It is connected to carbon directly. So we'll be getting S. 1 second. So oxygen will go and attack the carbon, which is connected with Br, 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 and here it will be like O minus and C. Okay, so now what will happen? This one will get in and Cl minus will move out. So therefore, we'll be getting the final product as I have like oxygen, Br, bond C, double bond O, bond B, Br, Br, and B. Okay, now we got like C is your major product. Okay, so clear with this, everyone? Are you clear? Yes, fine. Okay, so now what is the question asked? The total number of bromine atoms in the molecule T. So what is the total number of bromine atom in the molecule T? What is the total number of bromine atoms? So 1, 2, 3, and 4. So the answer is going to be like 4. 4 is the answer. Okay. Got with this, everyone? Clear with this question? Any doubts? Fine. Moving with the next question. Consider the following reaction sequence. You have like para-nitrotoluene on reaction with P gives Q, or Q on reaction with R gives yes. S on hydrolysis gives T. S on reaction with U gives benzoic acid. Okay, so what is the correct option? So four options are given over here. We have to evaluate and find out the answer. Okay, so starting with the given compound, it reacts with P. So what is the P given over here? Like check P. P is like hydrogen, palladium, ethanol, which is a reducing agent. 10HCl is a reducing agent. And here you have like benzene diazonium chloride along with N2 plus Cl minus. Okay, so nitro compound RNO2, nitro compound with benzene diazonium chloride. What will be the product you'll be getting? What is the product when nitro compound reacts with benzene diazonium chloride? What you'll be getting? You'll be getting like NH2. Okay, you'll be getting NH2. And here it directly reacts with another NO2. Okay, NO2 COOH. Here it is like COOH. Now I can just find out like odd man out. All these three will give you the same product. You'll be getting like NH3, sorry, NH2CH3. This is also like reduction. Here too it is reduction. When it reacts with benzene diazonium chloride, you'll be getting like aniline as the product. Okay, so you'll be getting like when I use option A, B, and C, I'm getting the same product. And then it's like you have to react. This is your Q. You're reacting it with R. You're reacting it with R to give S. Okay, to give S. So now again, you just check these three. Okay, you just check these three. Now, NH2, NH2 on reaction with NaNO2HCl, it is a diazotization reaction. Yes, HNO2, it is just nothing but a mixture of NaNO2HCl. It is also diazotization. Again, when you're reacting it with like, okay, this is your T. I'm sorry. This is like yes. This is yes. What is given is yes. Okay, so first just do these two. So these two are like same, right? So what you'll be getting is you'll be getting it as N2 plus Cl minus and CH3. Now this is your S. Now I got S in the option C. Okay, it is your S. And then what happens is it reacts with S reacts with water to give T. S reacts with water to give T. Okay. So when benzene diazonium chloride on hydrolysis, what product you'll be getting? What product you'll be getting? You'll be getting like phenol as the product. You'll be getting like phenol as the product. Okay. So therefore, here what I'll be getting is like N2Cl plus Cl minus will be getting OH, and here like CH3 is there. So put CH3 over here. So I'll be getting like cresol. Okay, so cresol is your T. You got T as cresol. So I have T, which is also right. Okay, so option C. I got T. Now, what is the next thing? S on reaction with U gives benzoic acid. So S on reaction with U gives benzoic acid. Now look over the options. Okay, so option is H3PO4, H3PO2 on reaction with KMNO4 and water. So first, when I react with BDC, benzene diazonium chloride with H3PO2, and what you'll be getting? H3PO2, I'll be getting like benzene as the product. Benzene as the product. Then benzene on reaction with KMNO4 water, then it will produce, it will get oxidized. So when I check over here, I have like first I will do for H3PO2 and then I'll do this one. Okay. So here this one will be hydrogen CH3 is there. Now when you react it with like MnO4 KOH, so the whole side chain will get converted to COOH. COOH. Now we got benzoic acid as the product. So option A is right, B is right, and C is right. So the correct answers are going to be like A, B, and C. When you take C, U is CH3, CH2OH. So instead of H3PO2, when you use like CH3, CH2OH, then too you will be getting benzene as the product. Okay. So clear with this question? Yes. Very good. Fine. So moving with the next question. The reaction sequence that would lead to formation of orthoxylene as the major product. So you have like four options A, B, C, and D. Okay, we are going to evaluate and find out what are all the options will give orthoxylene as the major product. Okay, so moving with the first reaction. First reaction. So this is like orthotoluidine, right? Orthotoluidine. Orthotoluidine reacts with NaNO2 HCl. So what you have is like NH2 you have. When it reacts with NaNO2 HCl, you'll be getting N2 plus Cl minus. So in all the reactions, what we have like seen so far in all the years, this question is like compulsory. Okay, in all the years, like the conversion of aniline to benzene diazonium chloride is asked. Okay, in like any form, it is there. So therefore, this is like very important. So aniline, when you have like NH2, it gets converted to N2 plus Cl minus. Cl minus. Okay. Now, second is like you are reacting it with CuCl. Again, this reaction we have seen, Gattermann reaction. So what will be getting? MECl. So it is a benzonitrile will be getting a product of benzonitrile, 2-methyl benzonitrile. And the third one is you are reacting it with dibol H. Dibol H, diisobutyl aluminium hydride. Dibol H is diisobutyl aluminium hydride. So what reaction, what reagent it is? It is a reducing reagent where CN will get converted to aldehyde. CN will get converted to aldehyde. So therefore, we'll be getting NeCH. So it is a reducing agent which converts CN into CH. Okay. So we'll be getting 2-methyl benzaldehyde. And again, this all reaction with hydrazine into H4. KOH when you heat. What product you'll be getting? And write this is like C double bond O H. Hydrazine N2H4. N2H4. Hydrazine. This is hydrazine. So hydrazine on a reaction with carbonyl compound. What will happen? Water molecule will be removed. So you'll be getting as C double bond N NH2. Okay, hydrazine. Now, in the second step, in this step, you put KOH. And when you heat this one. Okay. So what will happen over here is like N2 gas will be evolved. So you'll be getting CH. CH. So I got like orthoxylene as the product. So option A will give orthoxylene as the product. Okay. So clear with these conversions, everyone? Shall I move to the next option? Yes. Moving with the next option. So see this one, we know that carbonyl compound substituent. Okay, so when you have like NH3 or when you have like N2H4 hydrazine, yes, NH2OH. So with any the thing like any nitrogen substituent, what will happen? Water molecule will be moved out. H2O will be moved out. Okay, so everywhere. So here, like I have N2H4 hydrazine. Yes, so water molecule will be moved out to form like C double bond N bond NH2. Now this on reaction with the base. When it reacts with the base, so nitrogen gas will be moving out. Nitrogen gas N2 will be moving out, and it will take up like one of the hydrogen to form CH2. To form CH2. Okay, fine. So moving with the second thing. Second is, yes, it's Holzkirchner and MEBR. MEBR. Okay, so when you have like 1 bromo 2 methyl benzene, when it reacts with magnesium, whenever an halide reacts with magnesium, whenever a halide reacts with magnesium, what will be getting? What reagent will be formed? Alkyl halide, very good. You'll be getting Grignard reagent. This Grignard reagent, when it reacts with carbon dioxide on hydrolysis, what product you'll be getting? Grignard reagent with carbon dioxide and hydrolysis will get acid as the product. Okay, so that is what I'm going to write over here. So this Me will be, it will not be disturbed. This Br on reaction with magnesium will get MgBr, and on reaction with carbon dioxide and on hydrolysis, I'll be getting COO. Now what you're going to do, react it with thionyl chloride. Just now we have seen the reaction. SO2 HCl will be removed to form, what you'll be getting is COCl. Okay. Now you're reducing it with palladium barium sulfate. Palladium barium sulfate. When you reduce it with palladium barium sulfate, what will happen? Acid chloride on reaction with hydrogen, palladium barium sulfate. Can you just name the reaction? Yes, you'll be getting aldehyde. Very good. Rosenmund reduction. Rosenmund reduction. So you'll be getting like aldehyde as the product, CH. Now, zinc amalgam HCl. Zinc amalgam HCl. What is the name of the reaction? It is Clemmensen reduction. Very good. Clemmensen reduction. So therefore, you'll be getting orthoxylene as the product. So option B is also okay. Now moving with the option C. Okay, fine. So you have like an alkene. Okay, here you have in the side chain, you have an alkene. You're reacting it with BH3, H2O2, NaOH. Like, can you name the reaction? Very good. Hydroboration. Hydroboration, will it follow Markovnikov's addition or anti-Markovnikov's addition? Anti-Markovnikov's addition. It will follow anti-Markovnikov's addition. So where does this OH will go and attach? OH will go and attach to the carbon which has more number of hydrogen. So when I take here, I have one hydrogen. Here I have like two hydrogen. So OH will attach to more number of hydrogen. So MECH2. I got this. Fine. Now what we are going to do is we are going to react it with PBr3. Okay, you have alcohol. When it reacts with PBr3, what product you'll be getting? It will undergo substitution reaction. So SN1 substitution to form Br. To form Br. Okay, they'll undergo nucleophilic substitution reaction. So OH will be replaced with Br. Now, alkyl halide on reaction with zinc dilute HCl. Zinc dilute HCl. Zinc dilute HCl. So what will be formed over here? What will be formed over here? Oh, fine. See, this is CH2OH, right? So primary alcohol will undergo like SN1 or SN2. Primary alcohol will undergo SN1 or SN2. Like this space is empty, so it can undergo the backside attack to give Br. Okay. So tertiary will undergo SN1 reaction. Tertiary will undergo SN1 reaction. Fine. Now, with zinc and dilute HCl, what product you'll be getting? What is like this reagent? What is this reagent? Zinc and dilute HCl. Very good. Lucas reagent. Okay. So Lucas reagent with primary halide. Primary halide. Will the reaction will be immediate or will it be slow? With primary halide. With tertiary halide, it will give a immediate product. Okay, immediate turbidity will happen. But here it will be like very slow formation of the product, and the product formed also will not be orthoxylene. You have like ethyl group over here. Okay, so it is not orthoxylene which is formed. You have CH2, CH3. CH2, CH3 will be formed over here. So option C will not give orthoxylene. Okay, clear? Yes, moving with the last option. Okay, fine. So here you have alkene on ozonolysis with ZnH2O, whether it is a reductive ozonolysis or oxidative ozonolysis. Reductive ozonolysis or oxidative ozonolysis. Very good. Oxidative ozonolysis. And here, like, which is more reactive? It is more reactive, okay? And here the benzene ring, like due to delocalization, it is less reactive. So I'll be getting, what you have to do, just break the double bond and put oxygen on both sides. So you'll be getting like aldehyde and CH2, CHO. Yes, fine. So it breaks to form like two carbonyl compounds. Now what you're going to do is like you're going to react it with N2H4 KOH, heat it. So again, what will happen? Like this is, what is the name of the reaction? Ulf-Kirchner reduction. So Ulf-Kirchner reduction will give what? It will give the alkane. So you'll be getting CH3, CH2, CH3. You have like CH2 and C double bond OH. This will get converted to CH3. Okay. So here too, I got like, it is not an orthoxylene. Okay. You have like 2-ethyl, 1-methyl benzene. So here too, orthoxylene is not formed. So the correct options are A and B will give you the orthoxylene products. B and D will give you like, can you please give example of reductive ozonolysis? Fine, I'll give you the example. See, whenever there is a alkene, okay, so when I have like CH3, CH double bond, CH2, when you're doing ozonolysis, what will happen is it will form an ozonoid by breaking both the bonds. So it'll be getting like CH, CH2. Both the bonds will be broken down. So it'll be getting an ozonoid like this. Three oxygen are there. So it will form something like this. So this is your ozonoid. Now, what will happen when you do a reductive ozonolysis, like when you put zinc water, this zinc will take up oxygen and it will be removed as ZnO. So this part and this part will be completely clean. You can write the product as CH3CHO, which is on this side. And this side you have H2CO, which is nothing but HCHO, formaldehyde. You'll be getting the product. And reductive ozonolysis. But when you do like oxidative ozonolysis, like without any metal in it, when you simply put water, what will happen? It will form the acid. Okay, oxidation will happen to form CH3COH. And when you put zinc, reductive ozonolysis will happen. Or simply you can write the product as C. You just want to break the double bond, okay, and put oxygen on both sides. You'll get the reductive ozonolysis product. You'll be getting CH3CHO, HCH. What I've done, the same thing over here. In the cycle, I have broken down this double bond completely and put oxygen. So what you'll be getting here, it has like COH. Okay, so you have like carbon over here, and this carbon has one hydrogen. So you'll be getting like aldehyde as one of the product. Again, what you'll do is like add oxygen to this carbon. You'll get one more aldehyde. Okay, here too you'll be getting CH3CHO, HCH. Now, for instance, if I have like something CH3CH3 double bond CCH3. Now what you have to do is just break the pi bond completely, put oxygen on both sides. What you'll be getting here, CH3, CH3 double bond. You'll be getting a carbonyl compound that is ketone, and here you'll be getting an aldehyde, CH3CH, CH3CH, CH3COH. Okay, so simple thing when you do it for the reductive ozonolysis. For oxidative ozonolysis, just convert it into acid. Okay, clear? It is very simple. Okay, by not writing the ozonoid itself, you can directly break the double bond, put oxygen on both sides, you'll get the product. Fine. Now moving with the next question. Okay, so what are the correct options for the following sequence of reaction? Okay, so the options are given. You are just going to evaluate the thing. Okay, so Q is KNO2 and W is lithium aluminum hydride they have given. So here, if you put like QS KNO2, okay, Q is KNO2, and what is the second option? W is lithium aluminum hydride. Okay, just we are going to find out the path, whether it is going to right or not. Okay, so if you are evaluating this thing, you have CH3 is nothing but 12 on reaction with bromine in light. What you'll be getting? What would be P over here? P would be CH2Br. Okay, what is here like? In presence of light, it means that it undergoes homolysis. Okay, so you'll be getting monochlorinated product at the side chain, not on the ring. On the ring. Okay, that is different. Now you're reacting it with KNO2 and hydrogen, palladium, carbon. Now what is the product you'll be getting over here? Like KBr will be moved out. Getting CH2NO2. Again, this on reduction will give you energy. You'll be getting a primary amine. So now this is your R. This is your R. Now when I put again, if I'm getting R, I'm getting this primary amine. I have to check. So you are having like toluene with KMNO4, right? You have CH3 at the side chain. So when you read, it will get converted to C. Benzoic acid is your T. Now benzoic acid on reaction with ammonia, what you'll be getting? You'll be getting amide as the product, CONH2. Now amide on reaction with lithium aluminum hydride, will it give like R? Will it give like R? Yes, it will give you like TH, CH2, NH2. It will give you like TH, CH2, NH2. So I have got R. Okay, fine. And next is like, okay, so here there is like a correction. When you put like AgNO2, you'll be getting this thing. Okay, when you put a KNO2, what will happen is nitrite will be formed. AgNO2 will give you CH2NO2. But when you put like KNO2, what will be formed is it will give you like CH2ONO. Nitrite will be formed. So nitrite on reduction will not give the primary amine. It will give the secondary amine. Okay. So now if I put KNO2, this one will not work out. So option A is going to be like, okay. What about like option B? What about like option B? Option B is R is benzoin. Okay, benzoin. It is like benzoin or benzylamine. What is R? What you got over here is like CH2NH2. It is benzylamine, right? Not benzoin. It is not aniline. It is a primary amine. So option B is also going to be like wrong. Option C is Q is equal to AgNO2, which is right. R is phenyl methane amine. What is R? R is like phenyl methane amine or benzylamine or aniline, which is going to be like right. And when amide it reacts with lithium aluminum hydride, it gives amine. Okay, so W is right. And what about V? Where is V over here? Yeah, okay. So when P reacts with V, it gives yes. So what is V given? V is AgCl. With AgCl, will it give S? So what is P? P is CH2Br. So PH CH2Br, CH2Br on reaction with AgCN. Okay, what you'll be getting? You'll be getting like CH2 CN. You'll be getting CH2CN. Okay, which is S is like foul smelling. Now, when I take R and evaluate S, will it give the same compound? I have to check. So it is a primary amine with chloroform and KOH. What will be formed? What is the name of the reaction? It is carbylamine reaction. Yes, it is carbylamine reaction. So when it is like carbylamine reaction, you'll be getting RNC as the product, right? You'll be getting RNC as the product. But here RCN is formed. Here RCN is formed. Okay, AgCN. So therefore, which option is right? Like option C is going to be the right one. Okay, clear with this? Clear with this reaction? Any doubt? Yes, yes. What is the doubt? When V is AgCN, you have like CH2Br. Okay, so when CH2Br, when a halide reacts with AgCN, silver nitrate, what will be formed? Yes, it forms alkyl isocyanate. Sorry, here too it should be like NCN. Very good. So here too you'll be getting NC, here too you'll be getting NC. So option D is also going to be like right. I'm sorry. Here with AgCN, it will give you isothiocyanate as the product. Okay, clear? Clear now? Yes, it is also isocyanate. Yes, fine. Clear with this question? Fine. With this, we are going to end the session today. And tomorrow, we are going to like revise biomolecules. Okay, so go through biomolecules and we can do like more questions in biomolecules. In like aldehydes, ketones, and amines, we have done less question because like we have to sit and solve each and every equation. But if biomolecules, we can do like more questions. So go through biomolecules and come. Tomorrow we'll discuss the questions on biomolecules. Okay, fine. Thank you, everyone. Thank you.